So welcome and thanks for joining us today. My name is Greg Tiemann. I'm a product engineer on the real-time GIS development team in Redlands, California. I'm joined by my colleague,
Sagar Aire, and I also work as a product engineer on the real-time GIS dev team in Redlands.
So over the next hour, we're going to introduce some of the key real-time GIS capabilities of the ArcGIS platform. So just out of curiosity and by a show of hands, how many have actually started using the GeoEvent extension? All right, maybe 3, 4, 5. 5 people. Okay, great. Well, this should be a really great introduction to the capabilities. So we're going to cover pretty much everything you need to know about getting started with the GeoEvent extension. So let's take a look at the agenda here. And actually, sorry, wrong screen. So what we're going to do is take a look at what real-time GIS is. We're going to work with actual real-time streaming data in a couple of demos and describe how you get started doing so. We're also going to look at some of the ways in which you can apply real-time analytics to that incoming streaming data. We'll also look at how you can incorporate real-time data and features into your web applications, and then we'll wrap it up at the very end. So the first thing I like to do is start with what is really real-time GIS and set the context for what that means. So the data that's fueled GIS in the past was typically created to represent the state of something at a specific moment in time. So whether that was data that was collected for what has happened in the past, what is happening right now or currently, or what will happen at some point in the future. And what we're coming to find out is that that current snapshot, or what is happening right now, falls out of date very quickly. So especially in today's fast-paced and constantly changing world, that data is outdated almost as soon as it's created oftentimes. So what is real-time GIS data then? Well, we can characterize it really as a continuous stream of events flowing from a data feed or from a sensor. So if we look at a couple different user communities here and how they might utilize real-time GIS data, the first being law enforcement agencies. They might want to have a map of where all their assets are in the field. So you could have vehicles equipped with in-vehicle GPS devices that are constantly sending the location of that particular vehicle or the speed of that vehicle or other telematic information regarding that vehicle. You might have police officers that have, when they communicate over their radio, it might transmit their location every time they do so. Utility companies are also using real-time information for capturing the live status of their network. So while the sensors on their network aren't physically moving, the information that those sensors are capturing and sending back to presumably an operations center can update and change very rapidly. RFID is also used in a wide variety of environments to keep track of items of interest. So warehouses use it to track and monitor inventory levels. Hospitals use it to track and monitor to make sure equipment has been properly cleaned and gone through the stages before it goes into another patient's room, and many other applications for the use of RFID. There's also a wealth of volunteer geographic information available, so especially from federal agencies typically. So in the United States, USGS and NOAA provide a wealth of real-time data that you can consume for additional context in your applications and to provide additional situational awareness. So things like storm, wind, temperature, earthquake, and wildfire feeds can all be consumed in ArcGIS and as presumably real-time data. So modeling each of these in ArcGIS is pretty easy. The challenge comes in when we try to integrate this as real-time data. And the reason is because there's so many different data formats and sources and devices, and each typically communicates with a different set of protocols and a varying set of data formats. So connecting to and receiving the real-time data from this wide variety of sources is really the first requirement of any real-time GIS system. Now, while it's easy to connect a sensor to a feature and then display it in near real time, the next thing you might want to do is actually perform some additional processing or analysis on that data as you're actually receiving it. So in this scenario here, we're monitoring fishing vessels, and we're detecting when they're inside this no fishing zone that's represented with the red polygon. So in the illustration above that, what we're doing is applying a filter that's essentially going to continuously filter events inside that no fishing zone. And so when an event is found to satisfy that filter, we're going to add a new feature to this alert feature, and then those alerts will then be symbolized in the map differently. So you can see the vessels inside the red boundary are symbolized differently from those outside the red boundary. So the second requirement of any real-time GIS system is this ability to perform this continuous processing and analysis on that data as you're actually receiving it. So here we have another example of continuous analysis on a real-time stream of data. So in this scenario here, we want to notify a parent when a child leaves school property. So you can see again that we're updating a child's current location in the child feature class with the child's, their location. And then at the same time is what we're detecting is when that child is outside the school boundary. So when that child does leave that school boundary, the parent can be immediately notified via, in this scenario, email and text message that their child has left school property. So sending these kinds of updates and alerts to those who need it and where they need it is really the third requirement of any real-time GIS system. There obviously can be a lot of communities of interest that exist that may want to be notified in a different way. So having the ability to route these events of interest to these various communities is really important. And then equally important is that ability to provide these alerts and updates where they need it, whether that's on a mobile device or in a map or whatever it might be. So the real-time capabilities of ArcGIS really satisfy those three requirements I just highlighted and much more. So it allows us to really ingest high-volume, high-velocity data into ArcGIS from any number of data sources. So that could be data sources that include social media feeds, so RSS feeds, Instagram or Twitter, for example. We can connect to different in-vehicle GPS devices or GPS devices in vessels or trucks and collect that information and consume that information. We can also connect to sensors that might be out in the environment that are continuously sending in data about CO2 or other sensors that might be collecting other sorts of information on a utilities pipeline, as I mentioned before. We can also connect to different business systems as well that you might already have in your organization, as well as field crew. So field crew that have maybe working in a dangerous environment, maybe out on an oil rig, and they encounter a fall. They have a panic button. They click the panic button or whatever it might be, and they can be alerted, and the appropriate people can be alerted upon that incident. So once you bring that data in, you can perform this continuous analytics on the events as they're received. So doing things like filtering the data. So if you only care about a certain attribute in the data or a certain type of vehicle, for instance, you can filter out those vehicles from the rest of the data. You can also do things like enriching the data. So if you have a stream of data that's pretty slim on the amount of information, you can also enrich that data with other information from a table, for instance. You can also do things like detecting patterns of interest. So if you want to detect when a vehicle enters an area it should not have entered, you can detect those sort of patterns. Next, you can store these observations in both an enterprise geodatabase as well as the spatial temporal big data store that was released at the 10.4 release. And then visualize that high volume and high velocity data as either an aggregation or as discrete features. So if you have a million or 500 million points in the big data store, for instance, it doesn't make sense to visualize 500 million points at a statewide scale, right? So you can do an aggregation on that data to see where the hot spots are of that data. And then when you zoom into an appropriate level, you can see the actual discrete features. And lastly, you have the ability to notify those who need to know about the events of interest as they happen. So whether that's, as I mentioned, updating a feature in a map and alerting upon that or whatever it might be, or sending instant message or text message or whatever, there's many different options for outputs that we'll cover in this session. So with that, I'll hand it over to Sagar.
All right, thank you, Greg. So how do you work with real-time data in ArcGIS? Let's take a look at the high-level steps for bringing the features come alive. The first step in this process is to create an output connector to connect to your feature service or your stream service. Once you have your output in place, you need to import or create your GeoEvent definition. Now, what is a GeoEvent definition? It is a schema of your underlying incoming data along with their attributes and their data types. It's that a component of GeoEvent that tells what the input is going to be. Next, you need to create an input to receive your real-time data. Now, you need to connect your input to your output, and that is done via the GeoEvent services. So you need to publish your GeoEvent service. And at last, you can visualize your real-time features on a map, that is portal for ArcGIS or maybe ArcGIS Online, or in applications like Operations Dashboard for ArcGIS. Next, we move to the first demo of this session, making features come alive. And here we're going to track snowplows and pickup trucks on Operations Dashboard. So the first step in this process is to log into GeoEvent Manager. So let me log into GeoEvent Manager. As you can see, GeoEvent Manager is very similar to Server Manager, where you can create and monitor your inputs, your outputs, your GeoEvent services, as well as perform administrative tasks like creating and importing GeoEvent definitions, creating and importing geofences, as well as performing import and export GeoEvent configuration. So let's get back to Services tab. As the first process is to create an output, so I'll click Output, and I'll click Add Output. Now I'll be creating two outputs. First one is Add a Feature, and the second one would be Update a Feature. The Add a Feature output will help you to visualize all the features of a particular vehicle, and the Update a Feature output will help you to visualize only the latest features, the latest observation of that particular vehicle. So I'll create Add a Feature output. These are the properties of Add a Feature output connector, where I will name it as Plows Feature Service Out. And I'm going to connect to my default ArcGIS server connection. And I'm going to update a feature service, which is in the UC folder. And I'll select the feature service, Vehicles Feature Service. Before I proceed further, let's take a look at the feature service which is already published. So I navigate to server REST directory. So I am under UC folder, and I have a couple of services already published. I'll click the Vehicles Feature Service, and it has a Vehicles layer. I'll scroll all the way to the bottom, and these are the fields which are in the output, which is speed, heading, time, vehicle name, as well as geometry, which is point, x, y, z. Let's get back to output connector. I'll leave the update interval to 1. I'll click Save. So I have my first output connector here. Let's create the second output connector. I'll click Add Output, and I'll search for Update a Feature. Let me name it as Plows Latest. This connector has properties which are very similar to Add a Feature output connector. So I'm going to connect to my default ArcGIS server, and let me select the UC folder. And the service in this case that I'm going to update is the vehicle's latest feature service. Now the unique feature identifier, or the UID, is unique to every vehicle. In this case, it is the vehicle name. And I'll leave the update interval to default, and I'll click Save. So I have my second output connector over here. Next, let's move to creating or importing a GeoEvent definition. To do that, I need to navigate to the Site tab. Under the Site tab, we have GeoEvent definition page, and we have a couple of GeoEvent definitions which are already present by default after you install the product. But these two GeoEvent definitions are not meeting my criteria. So I can create a new GeoEvent definition, else I'm going to import a GeoEvent definition. So I'll click Import. So I'm going to import GeoEvent definition, which is from an existing feature service. So it's the same vehicle's feature service. And the unique feature identifier, as I mentioned, is the unique ID of every vehicle, which is vehicle name in this case. And I'll click Import. Now you can see that there is a new GeoEvent definition over here, which is vehicles, and it has various fields. Let's take at the GeoEvent definition. I'll click Edit. It has various columns, the field name, the type, the cardinality, the tags. The fields include speed, heading, along with the data types, that is double, string, integer, geometry. Fields like point, XYZ, which will be used to construct geometry in the later part of the session. There are a couple of fields like object ID and global ID, which the input will not be updating. So I'm going to delete those fields. Let me delete global ID, and I'll click Save. Let's get back to creating a service. The next step is to create an input. So I'll click Input. I'll click Add Input. Now the data that I have is in the form of a CSV file, and I'm going to push it on a TCP port. So I'm going to select TCP connector, TCP in input connector. I'll click Select. So these are the properties of TCP in input connector. I'll name it as plus TCP in. And let's take a look at the advanced properties. The port that I'm going to push is port 5565. And I'll instruct GeoEvent to construct geometry from fields. So I'll give the fields that have geometry. Point X, point Y, and point Z. And I'll click Save. So there I have the input connector. The next step is to connect your input to your output, and that is done using GeoEvent service. So I'll click GeoEvent service. I'll add a service. Let's name this service as Flow Service. And I'll click Add a Service. And you can see the service designer experience is like model builder type experience, where you can drag and drop your inputs, your outputs, and your filters and processors. Now Greg will be discussing about filters and processors in the next part of the session. Let me drag and drop the input that I created and the two outputs that I created. And I'll connect the output to input via connector, and I'll click Publish. Let's take a look at the Monitor tab. Now I have all the components for the service. That is the input, the output, and the GeoEvent service. But the data is not flowing. So let's take a look at the simulator. GeoEvent Simulator is a utility that comes out of the box with the product. It helps you to push data maybe real-time data or maybe streaming data or simulated data into GeoEvent. Now the data that I have is in the form of a CSV file, so I'll go ahead and select the CSV file. So I'll browse the CSV file. As you can see that there are various fields in the CSV file, and field 3 is time. And I'll click load. Let's take a look at the CSV file that I just imported. This is a CSV file. It has fields like speed, heading, time, vehicle name. I'm going to track 5 vehicles, truck 1 to 5. 2 of them are snowplows and 3 of them are pickup trucks. I'm going to connect on port 5565. I'll click connect. There'll be one event every 50 milliseconds. Let's take a look at the operations dashboard now. Operations dashboard is a client where you can view your web map as well as you can add your widgets to it. As you can see over here that there are no features getting updated because I haven't started my simulator. I'll start my simulator now. I'll click play. Now you can see that there are 5 vehicles getting updated on a web map. The breadcrumb trail that you see is because of add a feature output. And I've set a filter on the client side that I need to see only observations for the last 20 seconds. So that was about this demo, bringing features come alive. Over to you, Greg.
Great, thanks, Sagar. So next we're going to look at the other ways in which you can bring real-time data into GeoEvent extension. So we looked at in the previous demonstration using the received text from a TCP socket. There's a number of other out-of-the-box connectors that are delivered with and installed with the GeoEvent extension. So you can see here on the left the ability to pull an ArcGIS server for features. You can pull an external website for GeoJSON, JSON, or XML data. You can receive features on GeoJSON, JSON, or XML on a REST endpoint. You can receive RSS feeds. You can receive text from a TCP, which we just used, or UDP socket. You can also subscribe to an external web socket for GeoJSON or JSON data. So those are all the connectors that are available out of the box with GeoEvent extension. In the center column, we make a number of community-based connectors available out on our GeoEvent gallery. So those include things like ActiveMQ, RabbitMQ, some of the enterprise messaging systems, CAP, which is a common alerting protocol connector for alerts typically used in public safety and emergency response, connecting to Instagram, KML, NMEA, which is a standard GPS data format. So devices that transmit NMEA standard 0183, you can use that connector to connect to those devices and receive that real-time data. There's a number of AVL or in-vehicle GPS device support out there. So Sierra Wireless and Trimble and also a Twitter connector as well that allows you to ingest real-time streams of data from Twitter. We've also worked with a number of Esri partners who have developed connectors to meet their specific requirements and their use cases that their solutions provide. So CompassCom is another AVL partner that provides in-vehicle GPS devices for tracking anything from trucks to whatever it might be. ExactEarth has an AIS feed for all of the 250,000 plus vessels around the world that you can consume into ArcGIS using that connector. Some other social media aggregators like GNIP and Valarm and so on. So the key with these is these connectors in the middle column, we have a GeoEvent SDK. If one of these connectors do not meet your needs, you can use the SDK to develop your own connector based upon a certain protocol and data format that you might want to ingest into ArcGIS. And many of these connectors here in the center column also have associated GitHub projects where you can actually access the source code and then go out and modify, submit bugs, and extend the capabilities of those connectors to meet your specific needs. Now, similar to the input connectors, we also have a number of output connectors available out of the box. So the ability to add or update a feature, those are the two outputs that Sagar just demonstrated in the previous demonstration. The ability to publish text to a UDP socket, push GeoJSON or JSON to an external web socket, pushing text to an external TCP socket, sending a text message, emails, as well as instant messages. You can also send features to a stream service, and we'll touch on this. This is a new first-class service in Server that allows you to stream data directly to your client applications, and we'll highlight that towards the end of the session today. You also have the ability to add and update features to a spatial temporal big data store. So if you're dealing with large volumes of data and you want to archive and store those observations of the real-time data, you can write that out to the spatial temporal big data store. And again, out on the gallery, we have a number of different output connectors available for writing out to things like MongoDB and Hadoop, or some actually using some of the enterprise messaging systems like ActiveMQ or RabbitMQ to send instant messages or messages to your key stakeholders. Similar to inputs, you can use the GeoEvent SDK to develop your own output connectors. So if there's not one here that meets your specific needs, you can develop your own output connector to do so. Next, let's move into, we looked at how you actually bring real-time data in and how you get real-time data out. Next, we're going to look at the ways in which you can apply real-time analytics on that stream of data as you're actually receiving it. So you do so by defining a GeoEvent service, which Sagar demonstrated previously. And that GeoEvent service, as you saw, kind of defines the flow of your event data. Now, in between your inputs and outputs, you can define filtering and processing steps, and these real-time analytics steps that you want to perform. And you define what inputs you want to apply those filtering or processing steps to, and then what outputs you want to send the results to. So in this example here, this ambulance monitor GeoEvent service, we have an input that's receiving ambulance or vehicle data on TCP text or TCP port 5566, and then we are sending out data to many different feature services here on the right, so the ambulance feature service as well as an alerts feature service. Now at the same time, in the center here, we have a number of different processing steps. So we have a processor here that's detecting a certain speed and monitoring the speed of all the vehicles on that incoming stream of data. So presumably when a vehicle's speeding, you get an alert, right? Also dangerous area detecting, so doing geofence detection, detecting when a vehicle enters a certain area of interest. As well as proximity detector, which is kind of another geofence example. So tell me when vehicles, when we're within a certain distance to a hospital, maybe 5-minute drive time from that hospital. When that vehicle enters that geofence, that 5-minute drive time, you can see here we're writing out to an SMS text output as well as an email out. So we presumably got an email and text message to that recipients at that hospital saying we're 5 minutes away from the hospital. Please prepare yourself. So let's look at filters here first. So filters essentially allow you to eliminate geoevents based upon an expression. So building out what we had in the previous demonstration, we had that input going directly to the output. What we can also do here is we can add filters, and these filters can be attribute expressions that maybe filter events based upon a certain vehicle type. It could be spatial expressions that it filters the vehicles based upon their location relative to a given area of interest that you define. Or you can create more complex filters that combines both attributes and expressions. So with that, I'll hand it over to Sagar to demonstrate these capabilities. Yes, one question.
So if you have live feeds coming from NOAA or GIS or something like that, can you still set up a geofence around vertical vicinity?
Yeah, the question is, so if you have live feeds ingesting from NOAA or USGS, can you set up geofence around those or other facilities? Yes, you can. Yeah. All right, hand it over to Sagar.
All right, let's take a look at the filtering capabilities of GeoEvent. What we are going to focus is attribute filtering, spatial filtering, and combination of both attribute and spatial filtering. Right, so I'll work on the GeoEvent service that I created in my first demo. So there was the plow service. And you can see that you can add filters from the menu on the left. So I'll double click on filter. Let me name this filter as my filter. And we need to build up an expression for this filter. Let's say the use case is to track only vehicles of a particular type. In our case, I'm going to filter only snowplows on an Esri map. So I'll click Add Expression. And I'm going to select the definition, GeoEvent definition that I imported in my first demo. It was the vehicles definition. And I'm interested in observing only snowplows on an Esri map. So I'll select the vehicle type. And the operator in this case is equals, but we have a bunch of other operators as well, like matches, excess, greater than, less than, greater than, equal to. And the value would be snowplow, because I'm interested in only observing snowplows on the map. I'll click OK. I have a filter over here. I need to connect this filter, so I'll disconnect these connectors. I'll connect the filter over here. And I'll click Publish. Now you can see that there are less events on the out as compared to the in. Let's take a look at the operations dashboard now. You can see that only the snowplows are getting updated on the map. The pickup trucks, that is the blue icons, is their last known position before the filter was applied. So the breadcrumb trail is only for snowplows. If I click on this thing, you can see that there's snowplow, vehicle type. Let's say now the use case is if you are interested in observing vehicles getting updated in a particular high-risk zone on a map. Let's say I'll add the feature service that I already have, high-risk zone. So if you are interested in observing vehicles only inside this particular high-risk zone. Let's further work on the service. Let's import the geofence into GeoEvent. To do that, I need to navigate into Site tab. I click on geofences. I can add as well as I can import. I'm going to import a geofence. I'm going to import a geofence from an existing feature service that is published. It is in the default ArcGIS server and in the UC folder. And the name of the service is High Risk Zone Service. Let me select the category and the name field. And I'll click Import. Now there is a new GeoEvent geofence which is of the category steep slope, and the name of the geofence is Middle Fork Dry Creek. Let's get back to the filter that we were working because we will be using this geofence. I'm going to further edit the filter that I created. Let's say if you are interested in the geometry in a particular geofence. So I'll select the GeoEvent definition, the geometry, and the operator in this case is inside a particular geofence. So I'll select inside. Well, there are a bunch of other operators as well, like contains, crosses, outside, exits. Is it inside any of the geofence or all of the geofence? For me, it's going to be inside any of the geofence. And you can see that there is a geofence, steep slope. I select that. And I'll click OK. So I have my filter ready. I'll click Publish. Let's take a look at the operations dashboard, now you can see that there are vehicles that are getting updated only when they are inside this particular geofence. The vehicles outside this geofence are not getting updated. That's their last known position. When these vehicles in this geofence start moving out of the geofence, they no longer get updated. Once they start entering again back into this geofence, they start getting updated. Now, the third use case is a classic use case that I am interested in observing only snowplows inside a high-risk zone. So, which is a combination of both attribute and spatial filtering. So, let's work on the filter. So, I'll work on the filter and click Add Expression. I'll select with the vehicle's GeoEvent definition. And I'm interested in vehicle type. And the operator is again equals. And we are interested in tracking only snowplows. Let's take a look at the filter. When geometry is inside the steep slope and the vehicle type is snowplow, that's our filter. And I'll click Publish. Let's take a look at the map now. You can see that the snowplows only getting updated when it is inside this geofence. The blue icons are their last known positions. When this snowplow moves outside this geofence, it no longer gets updated on the map. And when it enters again back into this geofence, you have filter output, and that is why it gets updated on the map. So that was about filtering capabilities of GeoEvent. Now Greg will continue for the next part of the session.
All right, so the next thing we're going to look at is, so we looked at all the ways you can apply filters, both via attribute expressions, spatial expressions, and combined attribute and spatial expressions. Next, we're going to look at some of the other ways you can apply real-time analytics to your incoming streams of data. So you do so using processors. So processors, similar to the inputs and outputs, there's a number of different processors available out of the box. So you can see those here in the left two columns. So you have a buffer creator. So let's is a great one that allows you to create dynamic buffers on an incoming stream of data. So maybe you want to buffer a 50-foot buffer around all your vehicles. Maybe you want to have an incoming stream of a weather feed coming in, and you want to apply a buffer on that. So you could use a buffer creator to do that sort of thing. Another one is the field calculator. So the field calculator, let's say you don't have control over your incoming stream of data and the information that's sent. So maybe there's a temperature field on that incoming stream of data that is in Fahrenheit, and you want to, but you need it in Celsius. So what you can do is use the field calculator processor to actually do those sorts of calculations on the data and add new fields to your data. Another pretty powerful one that we'll look at here in a moment is the incident detector. So this allows you to detect really any pattern of interest that you might be interested in. So maybe when, as I mentioned earlier, a vehicle enters a dangerous area and you want to capture the duration of that incident. So how long was that vehicle inside that dangerous area? There's a number of others here as well. So calculating the bearing of a particular vehicle, where is it going to be in the next 1 or 2 minutes type thing. You also have the ability with the GeoEvent SDK to develop your own processors here, your own real-time analytics. So if there's not a processor here that meets your specific needs, you can use the SDK to develop your own processors, which you can then incorporate into your GeoEvent services as real-time analytics steps. So let's take a look at this. So we're going to build upon the previous demonstrations, and we're going to actually apply some processing steps now. So we're going to come back into Operations Dashboard. You can see I have several different operation views here. Operations Dashboard is a great application for viewing your real-time streaming data. So we're going to open up the snowplow incident detection operation view. You can see we still have the same grayscale base map with our steep slope zone geofence here. What I've also done is configured a number of other widgets here. So the first one is the incident alerts. So anytime we detect an incident, we want to see an incident alert appear in this widget. We also have a gauge widget that allows us to count the number of alerts we've actually received and keep a tally. So you can set thresholds. So anytime maybe you received over 10 alerts, then somebody needs to be notified, right? That, guys, we have 10 alerts here. Somebody needs to start really ramping up and resolving these things or addressing these alerts. We also have a vehicles widget here that's going to actually populate, when I start simulating data, the vehicle information for those 5 trucks that we've been working with so far, and then just a legend for informational purposes. So what I'm going to do is, again, use GeoEvent Simulator here to simulate this real-time data in. So I'm connected to the port. I've loaded in my CSV file. I'm going to play this data back at this rate. GeoEvent Simulator is a great utility for testing your environment and simulating real-time feeds of data and doing those sorts of things. So we'll click play. We should see the vehicles appear on our map here. I'm going to apply that same last 20-second filter that allows us to just visualize the last 20 seconds of these vehicles' location. You can see in the vehicles widget here, we now have our 5 trucks. You can see we're monitoring the speed of these trucks as they're navigating around. And again, similar to the previous demonstrations, we want to detect when a pattern of interest occurs. So in a moment here, you'll see truck, I think that is truck 2, has just entered a steep slope zone. And I just received an email and a text message on my phone here that says, and you see the other 3, so we have 3 total messages now appearing on my phone as well as in the widget when these vehicles are inside that dangerous area. So, the text message can read, truck 1, you're inside a steep slope zone, please proceed with caution, type of thing. So presumably I would be one of the drivers in one of those trucks. The driver doesn't need to know where the steep slope zone is. They can be alerted via an email or text message immediately when they enter that steep slope zone. And you can also see the number of alerts we've received so far. You also see we just received another alert here that truck 5 is speeding. So you see that alert appear in the map as well as in the widget. So presumably this truck was speeding. He was speeding essentially for 16 seconds. Now this other truck here too, you notice he's not moving right now. So we just received another alert that truck 4 is currently idle. So you can do these sorts of detecting when vehicles are idle for a set amount of time. So maybe it's 30 minutes. The vehicle should not be idle for more than 30 minutes. Maybe the driver's taking a nap in the back of a parking lot or something. You never know, right? So once that vehicle starts moving again, you can see the incident ended. So let's look at this on the back end and see how GeoEvent was configured to support those 3 different scenarios. So I'm going to log into GeoEvent Manager here. We have many of the same inputs and outputs that we looked at previously. I'm not going to go through every single one, but we're going to open up the actual GeoEvent service, which incorporates all those. So you can see, again, we have our input here that's bringing in the data from Simulator on that particular port. And we're updating the plows and plows' latest feature services with the latest vehicle information. And that's how we saw the vehicles appear in the map. What we also had here is several different processors. So we had the high-risk zone detector processor. What we did was define an opening condition here. So anytime the geometry of any vehicle or truck enters any of our high-risk zone geofences, we want to alert upon that and detect that pattern of interest. We also have a plow speeding detector. So when we received the alert, GeoEvent was continuously monitoring that feed of all the vehicles to determine when any of the vehicles exceeded 50 miles per hour. So when that vehicle exceeded 50 miles per hour, you saw the alert appear in the map. And the reason being is because we wrote a new feature to the alert feature service output. And so symbolized and the symbology being defined on that alert feature service, we were able to visualize the different types of alerts in the map. We also had a track idle detector. This is the one that was, this is actually one of the processors that we deliver on the GeoEvent gallery. In this one, we had a time setting for allowed for idling. So in this case, we had any vehicle that was idle for more than 7 seconds, we wanted to detect that pattern of interest. And following that, we used an incident detector processor to detect that true incident. So when the track idle detected that incident, it set the idle field to true. And so we used the incident detector to capture that information, idle equals true, and when that vehicle started moving again, we had a closing condition in this case where idle equals false. And so essentially we were able to write that idle equals true to the alert feature service and then symbolize that accordingly in the map. And one thing I did not mention is, if you recall, when the trucks actually entered that high-risk zone, I had 2 other outputs configured here, a text message output as well as an email output that you heard hopefully come through on my device here. So that one GeoEvent service essentially allowed you to perform that demonstration and detect all those patterns of interest. I'll hand it back over to Sagar now. We'll talk about some of the other additional real-time spatial analytic capabilities.
All right, thank you, Greg. Now let's take a look at some of the additional real-time spatial operators. There can be a feature which is inside a geofence, or a feature can be outside a geofence, or a feature can be entering a geofence or maybe exiting a geofence. A feature can be a line, and so a line can be intersecting a geofence, or it can be disjoint to a geofence. It can be completely within a geofence, or it can be crossing a geofence as well. Now here's an example of storm approaching the coast. Geofences need not always be polygons, they can be points as well. Here the storm is a polygon, and the ground stations are in the form of a geofence. The storm polygon has a buffer around it. When the buffer intersects the ground station, there can be alert that can be sent in the form of an email, and the email can have the link to the web map, which can help the crew at the ground stations to view the current location of the storm. You can import geofences dynamically as well, so that and set even expiration time on them. So some other department is updating a feature service, and those geofences get updated every 15 minutes, let's say. So you can have geofences from a weather feed or temperature feed or any dynamic feed. Now geofences can update or synchronize in real time. Here's an example of high-value shipment getting transferred from one place to another, and the cars in the shipment needs to stay as close as possible to each other. The cars have a geofence around them which intersect each other. The moment this geofence are disjoint, an incident is created, and the incident is closed when the geofence intersect again with each other. Moving on to the next slide, we can specify the scope of the geofence. Let's say if you want to track the course of a car, that is geofences that it is passing through, there can be a use case to determine if the car is inside all of the geofences or it is inside any of the geofences. Here's another use case where we monitor the equipment at the construction site. The equipment, being expensive, is not supposed to go out of the site. When the equipment moves from one geofence to another, a warning is sent, as you can see it on the screen. However, when the equipment moves out of all the geofences, an alert is sent. This incident stays as long as the equipment is outside the geofences. The incident is closed again when the equipment enters the construction site. So that was about spatial analytics in GeoEvent. Now Greg will continue for the remaining part of the session. Over to you, Greg.
All right, thanks. So we've looked at so far how you bring your data in, how you apply your real-time analytics on the data, and then how you update features and send that data out to your key stakeholders. So now what we're going to do is apply this to an actual real-world example. So we're going to look at how you actually add this data to your web applications that you can share with your constituents. So in this case, but first, before we do that, let's look at the two patterns in which you can get your real-time data into your web apps. So the first is to use feature layers, and those are pulling from feature services. So your web applications are essentially pulling from making, I guess I should say, your web applications are pulling to get those periodic updates from those feature services and feature layers. And this must be backed by an enterprise geodatabase. The second pattern is to send features to what is called the stream service. And this is what I mentioned earlier, was a new streaming capability, a new service available at the 10.3 release. So in this pattern, you're sending features directly to your client applications. You're bypassing the enterprise geodatabase. So you have a stream layer on the client side that's subscribing to the stream service on the server side, and then your applications are immediately receiving and displaying that real-time data. The second pattern, using stream services, allows you to achieve a much higher throughput of data with lower latency. One thing to note is that there's no persistence of the data when you use stream services. So you're not storing or archiving that data in your geodatabase. It's just for pure visualization purposes in your applications. So how does the streaming capability fit into the overall ArcGIS platform? So as I mentioned, you have the enabled on the server side is the stream service, and on the client side is the stream layer. And this is supported in all of the web applications which are JavaScript backed. So with hopefully support for these streaming capabilities coming in the runtime devices as well as the desktop applications coming later. So with that, let's take a look at how you actually work with stream services. So in this scenario, let's presume I'm a member of a team in a local government, presumably around Sandy, Utah, since that's the data we're currently using. And I want to set up a stream service that is essentially sending the vehicle data directly to my web application or my web map that is part of that web application. So you can see, again, we have many of the same input and same output here. But instead of writing the outputs to the feature service, I'm going to add a stream service and write these vehicles to the stream service. So let's come over to the outputs here. And I'm going to add an output. And we'll search for stream. So we have the send features to a stream service. So I'll select that output to configure. I'm going to name this plows stream service out. We're going to choose the GeoEvent definition that we've been working with so far. And again, this is the component of GeoEvent that understands the underlying schema of your incoming data. We're going to choose our default server connection, our UC folder. And you can see here, if we had existing stream services published, we would be able to choose one of these here. Since we don't have a stream service published already, what we're going to have to do is publish a new stream service. So we're going to click Publish Stream Service. We'll name this Vehicles. The geometry type is Point. And we're going to choose our display field name here. So vehicle name is the name we want to use as our display field. And I'm going to click Publish. So now we have a new stream service called Vehicles published here, and this is what we're going to use to send our vehicle data to. So I'll click Save. So now what we're going to do is create a new GeoEvent service. So I'm going to name this service Stream. Now let's do Plows Stream Service. Click Create. And again, we can drag and drop our inputs and outputs here. In this case, I'm going to drag our input and output to the stream service and connect that and not click publish yet because we're going to come into, I should say, ArcGIS organizational account. And within this, I have that existing web map that I've been using, but I also have another web map that supports this last demonstration. What we've also done is created a web application using the web app builder. And so in this scenario, we want to let our citizens of our city know when the streets are plowed. So they can come to a web map in this application and view the current status of the plows. So let's open up this particular web application, and we'll click View Application. So we just launched our application. You can see we have our standard dark grayscale base map and a number of features here. So we have our vehicles feature that will appear in a map when we start and publish that GeoEvent service. And we also have the current plowed status. So when a vehicle is plowing a street, presumably we should see the symbology of these streets change to either in progress, not plowed, or plowed. So let's go into GeoEvent Simulator now, and we will start to simulate that data in. And remember, these are features, the vehicles are now sent directly to the stream service and not the, well, where are my vehicles? All right. We should have seen some vehicles appear there. Oh, thank you. See? That's why I need to rely upon everyone in the audience for this, right? Okay. Thank you very much. So yes, I'll publish that. Now, we should see vehicles start to appear in our map. So let me go back to that. Sorry. And here. So now our vehicles are updating, right? So now you can see as the vehicles are navigating the streets, the symbology of the streets is designated by in progress or plowed as they're exiting each of those different street segments. So just another way you can use and add real-time data to your web applications. In this case, we sent that data to a stream service and then made that web application available to the general public, who can now see and visualize when their streets are going to be plowed or the current status of the plowing. So with that, we will move on to the wrap-up. So hopefully you've seen that ArcGIS is a dynamic system that enables you to perform continuous analytics and real-time visualization of your data. Obviously, this helps provide you a better understanding of our world and your environment and your specific applications. So these applications allow you to allows you to know what is happening as it happens, react and make smarter decisions faster, as well as be notified when events of interest occurred, as you've seen. So we have a number of really great resources available to you. So if you're just starting to use the GeoEvent extension, you can access a number of different tutorials at this first link. So the introduction tutorial is a very thorough tutorial that will walk you through essentially everything that I did today, just using different data, creating your inputs, creating your outputs, testing out some analytics steps, and then putting that information on a map. Notifications, if you're interested in some other of the notifications, not only just email and text message out, you can check out the notifications. If you want some more information on the stream services, that is also available, a whole tutorial devoted to working with stream services. And then if you're interested in utilizing the new Spatial Temporal Big Data Store, where you can stream high volume, high velocity data and archive a large amount of data, check out the Spatial Temporal Big Data Store tutorial as well. So we're very active. The team is very active on the GeoNet space. So if you have questions or issues that you encounter, the community and the team is very active, actually. We try to respond to your questions as quickly as possible. So there's a number of other real-time sessions available if you haven't seen those yet. The repeat of this one was right now. There's also another one that leveraging stream services, which is, I guess this morning, we didn't update this slide. So anyways, there's a number of other great ones here. Archiving and visualizing observation data will walk you through an hour's worth of time looking at the big data store that I mentioned, that new capability that was released at 10.4. A really great session on best practices. So if you want some tips and tricks for how to get started using the GeoEvent extension, definitely recommend the best practices. A fun session this afternoon on the Internet of Things. So this one is bringing in multiple different devices and actuating things and using Philips Hue bulbs and sensors on people and temperature sensors and things like that. So it's kind of a fun session. The road ahead is a great session on Thursday. This one, if any of you attended the plenary, we talked about the real-time as a managed service offering that's coming at the end of the year that allows you to ingest not only hundreds or thousands of events, but tens of thousands, hundreds, or even millions of events per second in a distributed computing environment. So if you want a sneak peek of what's coming next with the next generation of real-time GIS on the platform, definitely attend that. And the last one is another kind of fun one, real-time 3D GIS, so visualizing your real-time data in 3D. So with that, we really appreciate you guys attending. We ask that you fill out the survey. Any feedback, anything that you can provide to make our sessions better in the future is much appreciated. And we also have a survey too. If you're working with anything related to IoT and want to provide Esri some information on what you're doing so we can help drive future technology or markets that we want to pursue, then please let us know by following the link there and completing that very short survey. And then links again to the resources available here. So with that, we will now open it up to any questions that you might have. Yes, sir.
I have two questions.
Two questions, okay.
One is for the rendering on the web. What is our limitation? How many sensor data in a second?
So the first question is, how many events per second can you send into GeoEvent, essentially? So you can send upwards of 3,000 to 4,000 events per second into GeoEvent right now. The limitation is if you plan to write that to an enterprise geodatabase or the geodatabase to a feature service, you can only update around 200 to 300 maximum events per second. So that's why we released the stream service capability that allows you to bypass the geodatabase and get around that 200 to 300 events per second limitation. And with that, you can stream upwards of 4,000 events per second.
Second, we have the complex application like 911, European style 112. We have the project framework on the web. So is there any limitation to insert in that framework that the application that you do?
So the question is, can we integrate with your own applications? Without knowing your application, I really can't answer that. But if you want to talk after, we could have a more detailed discussion about, yeah, or come down to the real-time island also. And we can talk about a specific use case in your example. Any other questions? Go ahead.
What version of Esri, generation of Esri do you need to?
Sure. So the question was, what version of ArcGIS do you need, does GeoEvent support? So the first release of GeoEvent extension was at 10.2, and the current release is, I believe, soon to be 10.4.1. So, and you do need, it is an extension to server, so you do need ArcGIS server installed in order to install the GeoEvent extension.
Same version?
Same versions, yes. Any other questions?
Yeah, well, might be jumping ahead on the road to come, but is there any possibility to take that extension out of server and make it like a part of a runtime?
The question is there any way to take GeoEvent extension, decouple it from server and make it its own, what was it, its own application or part of a runtime?
Yeah, part of it.
I'm not aware of any plans to do that as of right now. So the real-time as a managed service, what's coming next is essentially bundling with the GeoEvent extension, GeoAnalytics, which is a new extension at 10.4 that allows you to do the batch analytics after you've brought in the real-time data on the big data store. So it's bundling the real-time GeoEvent, GeoAnalytics, and WebGIS in one managed service offering. So that would be probably the only alternative at this point that I'm familiar with. So.
There was one more question.
In the geoprocessing part, in the middle, can you, how many coordinate systems do you support? It can be in one coordinate system, a different, or it's just one?
The question is, does GeoEvent support multiple coordinate systems? So if you're working in local...
For instance, if you're getting data from external areas, so should it runs maybe on different coordinates?
Right.
And the application where you will be using
Right.
GPS data, is there any conversion or it has to be custom?
I believe, do you know the answer?
No, to my knowledge, I don't think so that you cannot do anything with converting from one coordinate system to another, like what you can do in ArcMap, like GP tools. You cannot project one coordinate system to another in GeoEvent processing.
Yep.
So probably, if you have data, I think.
Come down to the real-time island and let's talk to some of the developers and see if there's a way to even develop a processor that does that conversion for you, or if there's something already available.
I can see in one organization using this product would be, because we have a number of AVL systems
Right.
that are ready AVL system, and they all try different coordinates.
Right.
Different coordinate systems in our internal
Yeah.
GIS. So data is streaming in JSON format, so I would need to do some projection.
Yeah. I think we do have a projector processor also, I think, on the gallery, if I'm not mistaken. But I think that is an option. I think we can satisfy that requirement.
Another question, in the multi-server IWP environment, we don't have to install geoprocessor tool on each server, or would you recommend to install on multiple servers? So for instance, we have ArcGIS server that is one site, one cluster, but has three servers.
3 servers in it. So the question is, would you incorporate the real-time capabilities into that cluster, or would you keep them separate? So typically we recommend keeping depending upon the scale of data you're bringing in. If you're bringing in 5,000 vehicle positions every 1 second, then you're going to want to separate out so the resources so one machine is devoted to at least your real-time ingestion, right? So it's not competing with the other resources in your cluster, the map services and feature services and all the other stuff that you have published using servers. So typically what we recommend is you have a real-time servers, or a real-time server, and then your standard ArcGIS servers, cluster, whatever it might be. So ideally, just depending upon if you're only bringing in 50 vehicles every 2 minutes, then you could probably incorporate that into the existing. But it all depends upon your specific use case. And
And would you install, let's say it's 50 units, and we decide we would have in the same cluster as our servers for maps and geocoding service and so on. Would you install on all 3 servers or just pick one?
just one, yeah.
About the 3D,
Yes.
like GeoF has should be the 3D infrastructure.
Mhm.
And also, we are following also helicopter or any other vehicle.
Mhm.
These services at this time, can we use on 3D infrastructure on as a product? It is ready.
That's a great question. I would recommend attending the real-time 3D session. The Morakat on the real-time team was previously 3D, very, very interested in 3D, and then he joined the real-time team, and now he does a lot of the work with the 3D and real-time. So definitely come down the island and or go to this real-time
Yes.
3D session.
Yesterday at 3:30, Demo Theater 5.
I will
Yeah.
attend.
Yeah,
Yeah.
talk to him. He's.
Do you mean that?
I don't know, honestly. I don't have an answer for you.
But we are studying on it.
Yeah.
As we
Yeah,
study
yeah.
on that.
Definitely.
Okay, thank you.
Yep. That's for sure.
That question.
All right. Well, thanks so much.